So welcome back guys, and I'm here to make summary or explain the summary about chapter 11, the small network. To build a small network. So build small network topology. Typical small business network. Small network have simple design. Only a small number of network devices are needed. A small network usually comprises one router, a couple of switches, and the user PCs. A connection to the internet is achieved through a single one link, commonly either cable or DSL. Most of the managing task is related to the maintaining and troubleshooting existing equipment. Uh, the management of small network is usually done by employee of a third-party company. Device selection for a small network. So factors to consider when choosing a device in tradition. Those listed in the graphic includes OS features. So first we have security, second one is the QoS, third one is the VoIP, third one is the L3 switching, fourth one is the NAT, and the last one is the DHCP. Then IP addressing for a small network. The address space is a crucial component of a network design. All devices connected to the network require an address. The address scheme must be planned, documented, and maintained. Address space documentation can be very useful for troubleshooting. Address documentation is also very important when controlling resources. Redundancy in a small network. A network should be reliable by design, and network failures are usually very costly. Redundancy increases reliability by eliminating single points of failure. Network redundancy can be achieved by duplicating network equipment and links. A good example is a network link to the internet or to the server farm. Traffic management. Traffic type and pattern should also be considered when designing a network. A good network design categorizes traffic ordering to priority. Traffic sent to router without any priority. We have voice high priority, SMTP medium priority, instant messaging normal priority, and FTP low priority. And its cloud backbone network. Common application. Network application used to communicate over the network. Email clients and web browsers are example of type of application. Application layer services, programs that interface with the network and prepare the data for transfer. Then each service use protocols which define the standards and data formats to be used. Then our common protocols. Each of these network protocols define process on either end of a communication session, how messages are sent and expected response, types of messages, syntax of messages, meaning of information fields, interaction with the next lower layer. Then real-time application, basic components, infrastructure, VoIP, IP telephony, real-time application. So we have to scale a network. Several elements are required: network documentation, device inventory, and budget. Also the traffic analysis. Protocol analysis. A network administrator must understand the protocols in use in the network. Protocol analyzers are tools designed to help in the task. For a more accurate protocol analysis, it is important to capture traffic in high utilization times and in different locations of the network. The result of the analysis allows for a more efficient way to manage traffic. Employee network utilization. It is also important to be aware of how network use is changing. A network administrator can change in person its snapshots of an employee application utilization. Employee network utilization. These snapshots typically include information such as OS and OS version, non-network application, CPU utilization, drive utilization, RAM utilization. Documented employee IT snapshots will go a long way toward informing of involving protocol requirements. A shift in resource utilization may require an adjustment of network. Then, upon completion, Types of threats. Digital intrusion can be costly. Intruders can gain access through software vulnerabilities, hardware attacks, or stolen credentials. Common types of digital threats include those listed in the graphic, so web information theft, data loss manipulation, identity theft, disruption of service. Physical security. Classes of physical threats: we have hardware, environmental, electrical, maintenance. Types of vulnerabilities. There are three primary vulnerabilities: technological equipment, vulnerabilities in protocols, operating system, and network. Configuration. Vulnerabilities created by misconfigured device, default configuration values, and easily guessed password. Security policy. Lack of security policy. Software and hardware installation is not consistent with security policy, and no disaster or recovery plan. Typically, the devices under attack are the endpoints, such as servers and desktop computers, and of these three vulnerabilities can be exploited and used in attacks. Types of malware: we have viruses, worms, and Trojan horses. Reconnaissance attack: the discovery and mapping of system and service. Often not considered an attack on its own, goal is to acquire enough information on the target system or network to facilitate the search for vulnerabilities. Common tools rely mostly on free and public internet surveys such as DNS and WHOIS. Port scanners and packet snippers are also common use in reconnaissance. We have access attacks, attacks against known vulnerabilities and services. The goal is to gain access to information that they have no right to view. Access attacks can be classified into four types: password attack, trust exploitation, port redirection, and man in the middle. Access attacks. Then denial of service attacks. We have DOS attacks default to eliminate. Although simple, DOS attacks are still dangerous. Ultimately, they prevent authorized people from using a service by consuming system resources. To help prevent those attacks, it is important to have the latest security updates. Then we have the common DOS attacks: ping of death, SYN flood, DDoS, and the Smurf attack. Then backup, upgrade, update, and patch. Keeping up to date with the latest developments can lead to a more effective defense against network attacks. As new malware is released, enterprises need to keep current with the latest version of antivirus software to mitigate worm attacks. Patches for all known vulnerable must be applied. A central patch server can be a good solution for managing a large number of servers and systems. Any patches that are not applied to a host are automatically downloaded without user intervention. Then authentication, authorization, and accounting. The AAA service provide access control on network device. AAA is a way to control who is permitted to access a resource or authenticate what they can do while they are there, authorized, and what actions they perform while accessing the resource. Then the AAA framework can be very helpful when mitigating network attacks. Then firewall. Firewall controls the traffic and helps prevent unauthorized access. Techniques for determining what is permitted or denied access to a network include packet filtering, application filtering, URL filtering, stateful packet inspection (SPI), and come with endpoint security. Common endpoints are laptops, desktops, servers, smartphones, and tablets. Securing endpoint devices is changing. Employees, you need to be trained on proper use of the network. Policies often include the use of antivirus software and host intrusion prevention. More comprehensive endpoint security solutions rely on network access control. Device security overview. Default settings are dangerous because they are well known. Cisco routers have the Cisco Auto Secure feature. In addition, the following apply for most systems: change default username and password immediately, restrict access to system resource to authorized individuals only, turn off unnecessary service, update any software, and install any security patches prior to production operation. Password. Use strong password. A strong password has at least 8 characters, mix of uppercase and lowercase letters, numbers, symbols, and spaces. No repetition, misspelled words, and change often. Cisco routers support the use of phrase made of many words. Then basic security practices. Service password encryption, security password minimum on length, login block for 128 times 3 within 60, and then exact timeout, and also the enable SSH. Okay, that's all for the chapter 11. Hope you learn, and thank you.